Hi, Honors Chem. We're talking about stoichiometry still, and today we're going to find out how much excess reactant we have left over. So, in my last video, we talked about limiting reactants. It's the thing we're going to run out of first. And the excess reactant is what's going to be left over, but how much will be left over? That's what this is about. Okay, so here's our first example. We're going to take ammonia gas and combine it with oxygen gas to form nitrogen monoxide and water vapor. And if we have 20 grams of ammonia and 10 grams of oxygen, we want to find A, B, and C. What's the limiting reactant? How much nitrogen monoxide can be made in grams? And how much excess reactant will we have left over? So push pause and try to write this reaction and balance it on your own. Okay, ready? Push pause. Okay. Hopefully you're still writing it and thinking about it, but all I did to find the have numbers, like from our last video, was I converted how much we have of grams and I converted that into moles. Then I used my molar ratio from the reaction I just wrote and balanced to find the need numbers. And again, if you don't remember how to do this, go back and watch the previous video. So now we're going to look at our have and our need numbers, and we're going to figure out letter A, which one's the limiting reactant. So just now I figured out I have 1.174 moles of ammonia, but I need 0.250. That means I've got plenty and I'm not going to run out, which means I am going to run out of oxygen. I only have 0.313, but I need way more than that. So oxygen is going to be the limiting reactant. And that means when I do my calculations, I'm going to use the numbers for oxygen to do my stoichiometry. So here's our formula. Here's our equation. We have to have it balanced to be able to do this. And I start off with my limiting reactant. From the problem, I know I have 10 grams. I convert grams into moles. And then in blue, that is my molar ratio. The last step is converting moles into grams. And then my very, very last step is to write my answer in sig figs. Ugh, they never go away. So then we want to find the last part, letter C. How much of our excess reactant will be left over? You guys, this is one of the easiest parts. All we got to do is just subtract. Earlier, we found out a have number and a need number for our excess reactant. All we're going to do is just subtract them. And we're going to take our number that's in moles and convert it into grams. We're going to answer in significant figures, and that's the very last thing we got to do. So you can see that after I subtracted 0.25 from 1.174, I got 0.924 moles. But the question isn't asking for moles, it's asking for grams. That's why I needed to convert it. So this is a new problem, example number 2. When we have mercury 2 hydroxide and we add it to phosphoric acid, mercury 2 phosphate and water are produced. So if you have 25 grams of each reactant, which one is the limiting reactant? And how much in grams of mercury phosphate can be produced? And how much excess reactant will we have left over? I would like you guys to try to write this reaction without me. I know I already put it up there. But if you can go back and try to balance it without me and write everything out, I also expect you to know the phases of each reactant because we learned solubility rules. So now we're going to answer part A. We have 25 grams of each reactant. That means mercury 2 hydroxide and phosphoric acid. So the first thing I do is convert those numbers into moles. And I'm putting up my reaction, my balanced reaction, so you can see it because we're gonna use it right now. Whee! So there's our previous work where we found the have numbers, but now we have to use our molar ratios that come from that balanced chemical reaction to find the need numbers. So the need numbers are in green. The have numbers are circled in purple but written in orange. It's a pretty colorful video this time. And now we just have to look at those numbers and figure out which one's the limiting and which one's the excess. So as you can see, my limiting reactant is going to be the mercury 2 hydroxide. So now I can actually answer letter B. And I'm going to use that number, 25 grams of mercury hydroxide, to do my stoichiometry. And that yellow part is my mole ratio. It comes from my balanced equation. And then the last part that's written in like aqua is me converting from moles back into grams. In this problem, we have two significant figures. So my answer has to be two significant figures. Okay, now we can answer letter C. How much are we going to have left over? All I have to do is subtract. So I'm going to take 0.255. I'm going to minus 0.071, and that gives me 0.184. And remember, these numbers are representing moles. But the question is asking for grams. So the last thing we got to do is just convert. And then don't forget your sig figs. All right, example number 3. When iron 2 sulfide reacts with oxygen gas, the products that form are sulfur dioxide and iron 3 oxide. So push pause and try to see if you can write this reaction and balance it without me. And if you can't, there's some help. And I'm just asking the same 3 questions over and over. Which one's limiting? How much can we make? And which one is the excess? Or how much excess will we have left over? So we're going to do part A. We want to figure out which one's the limiting reactant. Here's my written balanced reaction. On the left, I convert from grams to moles to find the have numbers. On the right, I use the number of moles in my molar ratio to find the need numbers. And I'm going to compare them here in a minute. Whee! Like now. So here we go. Now I can see that my iron 2 sulfide is going to be my limiting reactant because I don't have enough to actually make this happen. So if you hear this panting, it's Chewy. All right, so since I know which one is the limiting reactant, that's the number that I'm going to use to do all of my calculations. And the mole ratio in purple is the two things that I'm comparing. I'm comparing my limiting reactant to sulfur dioxide. That's why I'm pointing to both of those. So that's my molar ratio in purple. The last step is converting from moles back into grams. And we had 2 sig figs in that problem. So that's why my answer has 2 significant figures. Now letter C, we just need to figure out how many grams we'll have left over. Like I said, it's really easy. We just subtract the need number from the have number. That's how I got 0.426. We're going to convert 0.426 moles of oxygen into grams, and that's it. You guys don't give up. Chemists try. All right, have a good day. Or night.